much that's how that went. Okay, so we did this last year. This is like the first step. We're going to solve exponential equations, and to do that, we have to have common bases. And so I want to just review a couple things before we go on. So if I multiply x squared times x to the third, what do I do with the exponents? Add them, so this becomes x to the fifth. Yes, this is going to be on that buff color paper, and then we're going to do some more tomorrow, so don't lose this. What? I don't know. Maybe. Okay. No. No. What did I just say? I just said no. I just did. You want to fight about it? Let's go. Yes, I'm recording. I'm getting ready to fight Joseph Campbell. Okay. So if I have x squared times x to the third, we got x to the fifth. Does it change if I add a variable here? So this would be 2 to the 5x. So what happens if I add 3x plus 4 and 5x plus 6? Does that change? We just add it all together, correct? So the 3 plus 5 is going to give me 8x, and the 4 plus 6 gives me 10. And so if I want to write things with common bases, 9 is 3 to what power? 2. But if I want 1/9, what does that 2 become? -2. Okay, I want to review this too. So if I have this and I want to expand it, I'm going to do the bottom one. So I get, what happens to the variable? Okay, so I have 2 log of x. And then where does the 3 go? And it's minus. And the 4, so it's minus 4 log of n. But can I write this if I factor out the -1 here? So are these the same thing? They are. Okay, so keep that buff. We're going to use it again tomorrow, okay? Okay. So, this is what the exponentials look like. In number 1, they have common bases. The 3 is the same. So if the 3 is the same, I can just set the exponents equal to each other and solve. So for the first one, I would get 2x minus 9 equals 7, because the 3's are the same. And 8 is a solution, so we're going to put it in the braces. Would anything change for number 2? The e is the base, right? We just set the exponents equal to each other. So, y'all, there's 16 of these problems, and I don't want to have to work all of them. So I'm going to move to the hard ones, okay? And so I'll point some stuff out as we go, but I'm not working all of these. Okay, so I am going to do number 4. So number 4, it was like what we just did at the beginning. All of the bases are the same, but what do I have to do with the exponents now? Do what? Combine. So we're going to add, correct? So I'm going to add all the way across. So I'm going to get k squared plus k plus 2k minus 9 is 4k plus 11. So we have to add, because we're multiplying, we have to add all of the exponents. So when I do that, I get k squared plus 3k minus 9. So I combine like terms. So because there's a k squared, I have to move everything over to the side with the k squared. So I'm going to subtract the 4k, and I'm going to subtract the 11. So I get k squared minus k equals minus 20 is 0. So if I factor, so my k is 5 and negative 4. So if there's a squared, you have to move everything over, okay, and factor. So if we go on and look at number 6, do I have common bases here? So I have to make them common bases. So what do you think I could use? What's the base here? 4. So I want to make 64, if I can, something with a 4. So it would be negative 3. That's correct. So I'm going to have 4 to the negative 3 equals 4 to the a squared minus 4. So now are they the same? So now we can do the exponents. So I have negative 3. I'm going to add the 3 to the other side. So I get a plus or minus 1 here. So we're going to do the same thing on number 8. And so what do you think the common base here is going to be? Okay, so if I made this 6, what's 6 times 6? But this is a 12, this is a 12, and this is a 12. So isn't it already the same base? Yes, except this, I'd have to make this times negative 1, correct? So I'm going to multiply this times negative 1. So this is what I get. So I want to add these two together. So I'm going to have minus 4x minus 3 plus x squared. Do we like it with the x squared at the end? I don't like it that way. So we're going to move the x squared to the front. And there's an x squared, so I have to move these two over here to this side. So I'm going to subtract 2x and subtract 13. So I get x squared minus 6x minus 16 equals 0. So that factors. So I get 8 and negative 2. So is everybody good? Any questions before I go on? Okay. All right, everybody try number 10. So can you use 8? No, because 8 times 8 is 64, and times 8 again ends up being, what is it? 512. So I need a common base for my 8 and my 28, 128. So that's 2. So 8 is 2 to what power? Third. And 128 is 2 to the 7th. So once you have those, then you have 2 . So Ruben, what were you saying the problem was? What happens? So I get 6 minus 3v equals 7v plus 21. What do you mean they stay the same? I don't see anything the same. All right, so do I have a squared this time? No squared, so the variables go on one side and the numbers go on the other. So if I add 3v, then I'm going to move the 21. That is just too much information. Okay. Oh, yeah, sorry. Do you really have to go that bad, Taylor? I mean, Jordan. No, I did. I called you Taylor. Do you really have to go that bad, yes or no? Go. All right. Okay. Common denominator on number 12, what would it be? 4. So this is 4 to the negative 1. Is this plus? Minus? And then this is 4 to the negative 3. I can't see it up here. It's not like you can't see it on the thing.
It says 2x squared minus 5.
You can't see that minus.
You see the little dot, so you know it's a minus.
How do you know it's not a plus? You don't. But my eyes are bad. Okay, so when I distribute, I get this. Now, do I have an x squared this time? So you have to put everything on one side with the x squared. So I'm going to add the 6x squared. So I get 4x squared minus 9. And then what do I do with that? I'm going to factor, so I get 3x plus, 2x plus 3 and 2x minus 3. So my x is plus or minus 3/2. Okay. So let's do number 13. Did I tell you how to play football? Did I tell you how to play football? No. No, I didn't. So what would make you think you could tell me how to teach? Shh. All right. So looking at the 36 and the 216. I'm going to have common bases. So what are we going to guess is the common base? 6 is the good guess because 6 times 6 gives me 36. So that's 6 to the second. So 6 to what power is 216? So here I have 6 to the 2 times, is that y? P? That's a P? I'm not listening to any of you. So 1 over 36, what does that become? Negative 2. So it's 6 to the negative 2 equals 6 to the third. So 2 times 2r gives me 4r minus 2 is 3. So you add the 2. All right, pick. Which one do you want, 15 or 16? All right, so 16. Somebody take a guess. What do you think our common base is going to be? It might be 2, but what did we decide 8 to the third power was? 8 to the third power is 512, right? 8 to the second power is 64, and 8 to the first is 1 over 8. So I'm going to have 8 to the third. So this is negative 2. Negative 1. So on this side I have 3y squared. This side I have minus 6y and then minus 5y squared. Now what do I do? Move what? 3y squared or these two? 3y. All right, if I subtract 3y squared, I hate having the negative at the end. So can I divide this by negative 1? What happens if I divide by negative 1? So nothing changes, right? So I get 0 is 8y squared plus 6y. So what do they have in common? And 2y. So now I get 2 answers. You have to set this equal to 0. And you have to set this equal to 0.